How to interpret tables. These are examples of tables. Use tables if you want to enable readers to look up specific information. They will be able to find data that applies to them like age and gender, income range, product preferences, population, and the likes, often faster in a table than in a text. Before interpreting data, one must know its essential parts. A table consists of 6 important parts. First is the table heading, which consists of table name and table number. On the left side of the body are stubs, which are classifications or categories. Next is the box head, which refers to the top of the columns. Next is the body, which is the main part of the table. At the bottom part of the table are what we call the footnotes and the source note. For example, this is the table heading comprising of table number and table name. Stubs A, B, C. Box head 1, 2, 3, 4. Body, footnote, and source note. Now we are ready. Here are 5 steps in interpreting tables. Let's take this as our sample table. The first step in interpreting tables is to find out the scope. Here we need to look at the title, the column labels, row labels, footer, and source. With this given table, we may write step 1 like these. Table 2.3 presents the age distribution of students from 4 to 18 years old, grouped by gender. Or we may write, Table 2.3 describes the age grouping of male and female students from 4 to 18 years old. Let us now proceed to step 2, which involves examining the box head for additional information that needed to be mentioned. Or examine if the box head contains digits that need further clarification, just like this. Also, to get a general impression of the data by checking out the largest and smallest values in one or more categories. For our sample table, we need to mention that the data were also classified into residents and non-residents. So with this table, we may state it this way. They were further categorized into residents and non-residents, or the students were further grouped into residents and non-residents. We are now in step 3. How do the data differ? Here, look at differences in the values of the data in a single data set, a row or column. Looking at the male and female categories as well as the total number of students, we may write step 3 in this manner. As can be seen on the data, there were a total of 50 resident and non-resident students, of which males 32 were almost twice as many as the females, 18. Of the male students, 17 were residents and 15 were non-residents. The female students had a similar ratio as the males, 10 residents and 8 non-residents to be exact. Deductively, the number of male students were higher by 28%. Moving on to step 4 now. Where are the differences? Here, we need to find the relationships that connect the variables by looking into the data at the body of the table. Looking at the students' age distribution and categories, residents and non-residents, we found out that almost half of the students' population were of preschool age, 20 or 40% 4 to 6-year-olds, while 38% of the students were of elementary age, 7 to 9-year-olds, and 10 to 12-year-olds. The rest were 7, 13 to 15, and 4, 16 to 18-year-old adolescents. Interestingly, of the young schoolers ages 4 to 12, 21 or 42% were non-residents. Only 18 or 36% were residents. Comparatively, of the older group ages 13 to 18 years, the opposite is true, as there were more residents, 9 or 18%, than non-residents, 2 or 4%. Now we've come to the final step, Step 5, Summary. If you're interpreting data as a standalone, then you may state the summary by giving a final comment on the data as a whole. However, if you're explaining it in context with, say for instance, a research or an article, then you may answer the question, why are there differences, to state the summary. For example, as a final comment on this table, we may state, on the whole, there were more primary age students than high schoolers. Or we may write, the overall age grouping leaned towards more on the younger age students than the older ones. Or, looking at the entirety of student age distribution, there were more young students than older ones. Or, we can also say, generally speaking, a great number of the students' population were young. They comprised more than 3/4 of the entire student population. Or if we are to explain the changes or relationships in the data to state our summary, then we may write, taking everything into account, the high number of primary age non-resident students may have been due to the recent spike in the number of immigrants in the country. Or, considering these, the high number of young students could be attributed to the recent opening of the school's bilingual program, which possibly had attracted both resident and non-resident students. To put everything in a paragraph form, our table's interpretation would look like this. Please take a moment to read this. Also, I would like to remind you that getting acquainted with the different tables or graph languages will help a great deal in describing or interpreting them.